And now for one of the coolest things in your A-level, in my opinion, Doppler scans. So here's a blood vessel and there's a red blood cell, and so the green arrow shows the direction that the blood is moving. And we can imagine fairly easily that for doctors, being able to look at blood flow around the body is a useful thing to be able to do. So what they do is they fire ultrasound waves at the blood vessel. So let's say that's an ultrasound wave coming in there. And then it's going to bounce off the blood and reflect back and then be detected by our transducer there. But now, if you remember from when we did the Doppler effect, if you have something that's emitting a wave and it's moving towards you or away from you, then that's going to change the speed of the wave and the wavelength of the wave that's coming towards you. Now, in a similar way, if an ultrasound wave bounces off something that's moving, then that changes the frequency of the wave that's reflected. And so the ultrasound wave that bounces off the blood, moving blood cells, comes back up. It's going to have a different frequency. And of course, physicists have worked out the formula for it. So here it is. Again, it's a horrible looking one, but it's on your formula sheet, so you don't need to remember it. And so this has got the frequency there of the original ultrasound wave. And then this, if the frequency of the reflected wave is, what should we call it, F1, then the change in frequency is the difference between those two. C is the speed of sound in the tissue. Obviously, you put the ultrasound transducer as close as possible to the blood vessel there. The V is the speed of the blood flow. And then the theta is this angle here. So the angle between the flow and the direction of the sound wave. And so this is how you can work out the speed of the blood flow using an ultrasound scan. And notice, if it's going one way, you're going to get a positive change, and if it's going the other way, you're going to get a negative change. So you're going to be able to tell not only how quickly, but also what direction the blood is flowing. And incredibly, computers can take this information and they can make real-time images of the blood flowing around the body of an unborn baby still in its mother's womb, which I just find mind-blowing. It's amazing. Okay, I have not yet seen an example where you have to use this formula. So what we've got for question 4 instead is a very common question, which is describing how the Doppler scan works. So have a little go at that. And the 4 marks are for this. Number 1, you place the transducer at an angle to the artery. Number 2, you send ultrasound pulses in, and these are reflected off the blood cells. Number 3, the frequency of the reflected wave is different to the original frequency. And number 4, this allows you, this difference in frequency, this change in frequency allows you to work out the speed of the blood. And if you put the formula, that's great, but you will need to say what everything in it stands for, apart from the angle. They let you off with the angle.